Hey guys, it's Mrs. Bernal, and I'm going to be doing lesson 10.5 notes with you, independent and dependent events. And if you're in my 7th grade advanced math class, that is actually chapter 15, section 5. Okay, so the learning target for today is you guys are going to be able to determine the difference between independent and dependent events and use them to determine compound events. All right, and I wrote a little bit more than I thought I would. Okay, and yes, I'm writing in cursive, so that's a good skill to know how to read and write in cursive. Okay, so determine the difference between independent and dependent events and use them to determine compound events. All right, so, and really we're talking about probability for all of these. So the probability of the independent and dependent events and the probability of those compound events. All right, so when the occurrence of one event does not affect the likelihood that the other event will occur is called independent events. So for example, if we take a look, if we look at flipping a coin and spinning a spinner, what is the probability of spinning a prime number and then flipping tails? Well, if I spin this, no matter what I land on, it's not going to affect at all what the coin does. So the events are independent of one another. Independent. Because they do not affect, one does not affect the other. Okay? All right, so I'm going to pause there. You can pause and make sure that you have everything written down that you need to. All right, the next thing we're talking about is dependent events. So when the occurrence of one event does affect the likelihood that the other event will occur, we would call those dependent events. All right, so let's take a look, for example, finding the probability of dependent events. People are randomly chosen to be game show contestants from an audience of 100. You are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first, and then the second one of the people chosen is a friend of yours, and they're picked second? So what do you do to figure this out? So first we need to look at the probability of the first event, right? So this is the first event. So 5 of the people that you're with are relatives. So 5 out of the 100 people of the audience are your relatives. Now, one of them is chosen. So the remainder of the people left in the audience is really 99, and 6 of them are your friends. So this would represent your friends after one of the relatives is picked or chosen. Okay? So first, what you've learned from the other sections is that you need to simplify when you can the probabilities. So I'm going to simplify this. So really 5 out of 100 is equal to 1 out of 20. And then 6/99 is really simplified to 2 33rds. Okay, so now we have these 2 different events, but they are dependent on each other. So this occurring affected the total right here, this 99, because 1 was chosen, so now we have 99 people left. All right, so when these dependent events occur, one depends on the other, you simply multiply the two probabilities to find out what the probability of the dependent events is. So we're going to multiply these two together. So I want you to go ahead and try. What do you do? Well, you multiply across. Remember, when you multiply fractions, you're multiplying across. Okay, so when you do that, you should have gotten 2. And then if you wanted to, you could put it in your calculator if you did the work on the side. 20 times 33 ends up being 330. I'm sorry, not 330. That's when we simplify. Hello. It would be 660. Good thing I use a pencil. You should always use a pencil. All right, and then when you simplify, it's 1 out of 330. Now, if we were to put this in a calculator and we were to divide 1 divided by 330, the answer would be 0.003, which in percentage, we move the decimal twice, that is 0.3%. So the likelihood of one of your relatives getting picked to be part of the game show and then one of your friends getting picked, the chances are 0.3%. The chances of that happening. So if you ever get tickets to go see The Price is Right, and there's 100 audience members and you take 5 relatives and 6 friends, that is what are the chances that one of your relatives will be picked and one of your friends are picked. Now it changes, right? If we say, what is the probability of either your relative or your friend being picked, right? The chances go up, but we are looking at these dependent events happening one after the other, and that is the chance. All right, so remember, as you need to, go ahead and pause and stop and take notes. So this was page 1 of our notes. Okay, and remember, learning target was to determine the difference between independent and dependent events and use them to determine compound events and following the probability of those. Okay, so on your own, I want you to try. You're going to pause and you're going to try these two and then see what you get. And when I come back, the answers will be there. Okay, so here are the answers. And I just want to talk through with you on these. So what's the probability of spending a multiple of 2 and flipping heads? So looking here back at the spinner, there are only 2 numbers that are multiples of 2, 2 and 4. And there was 5 numbers. So 2 out of 5. And then flipping heads is a 1 out of 2. We multiply those events to see what the total probability is of getting a 2 and then flipping heads. We're not saying that they're dependent of each other. These are independent events, but we just want to know what the probability is of this compound event, right? Because there's 2 of them together. Independent events. I just want to make sure you guys remember that those are independent. And then when we simplify, we get 1 out of 5. So the probability is 1 out of 5, or this ends up being 20% chance of getting a multiple 2 and flipping heads. Okay, number 2 is much more involved, but if we break it down, this is going to be okay. So what is the probability that you, your relatives, and your friends are not chosen to be either of the first 2 contestants? So there's 1 of you, there were 6 of your relatives, and 5 of your friends. Remember from the first one? Oh, do I have it backwards? I think I have it backwards. That's okay. It's still the same. Okay, so there were 5 relatives and 6 friends. Okay, but total, so in your group, there are 12 of you out of 100. Now it says not chosen to be either the first 2 contestants. Well, if there's 12 of us in our group, including yourself, that means 88 are not in your group. So I just subtracted 112. So I went 100 minus 12. That gets us to 88. Okay, so 88 out of 100 is not chosen. or I'm sorry, not chosen, but not your group, right? One of those is taken to be on the game show, there's 87 of those people left, but out of 99. So now I have these two probabilities of these two events. This is the first time someone gets picked. The second time someone gets picked, and they're not in your group, right? They're not part of your relatives, or your friends. So when you multiply across, you get, and again, you can use a calculator, 7,656, and you get 9,900. Now, simplify it. I think the best way to do this would be just to keep going by twos. You're going to have to simplify it quite a number of times to get down to the simplest form, but I am going to give you a little help here. The largest factor of both of these numbers ends up being 132. So you get a simplified probability of this compound event of 58 over 75, which when you divide the top by the bottom, you get about 0.773, which that translates to 77.3%. So there's a high chance, right? It's very likely that someone else will be called and not in your party, right? So that is how we find that. Okay. So here we go. Now we're looking at the probability of a compound event. Finding the probability of a compound event. So I'm not going to read it to you. Just read it on your own. So I want you to pause and read this, and then we're going to talk about it. So I'm going to pause, you pause, and take. Okay. So looks like every answer has, every question has 5 possible answers. So guessing correctly, there's only one correct answer. So this one is 1 out of 5. This one is 1 out of 5. This one is 1 out of 5. So if you don't study, right, and you're just guessing, what's the probability you're going to guess all of these correct? So you multiply all of these probabilities by each other. When you do that, you find out you only have a 1 out of 25 chance of guessing all of them correctly. If you were to divide that, that ends up being just 0.8%. So less than a 1% chance you're going to guess correctly. So that's why you should be studying always. Okay? All right, so this is the notes for independent and dependent events and how they translate to looking at compound events. So if you have any questions, please contact your teacher. And if I'm your teacher, contact me. So get to it. And if need be, re-watch, pause, and write down things as you need to. Okay, have a great day, guys.